Hello, it's Mr. Norris, and in this video we're going to try to expand your knowledge of exponents. You probably do know a few things about exponents. For example, if I take 2 to the third power, that's the same as 2 times itself 3 times. So 2 times 2 times 2, and that's ultimately going to get me to 8. I could do 4 squared, which is 4 to the second power. That's the same as 4 times 4. That's going to get me to 16. You've probably even seen negative numbers raised to a power. So I could take negative 5, I could raise it to, let me go back, could raise that to the third power. So that's the same as negative 5 times negative 5 times negative 5. So let's think about that. That is a negative times a negative, which makes a positive, and then a positive times a negative, which gets me back a negative. So my final answer will be negative 125. But when we're thinking about this, what sort of constraints, what sort of rules are we applying to some base, the number, that we're raising to some power? What's special about these exponents? Most likely, when you've studied exponents in the past, you've had some number, which we call the base, and it's raised to some power. But that power is always a positive integer. You may raise something to the second power, or to the third power, or maybe even to the 100th power if you're having a calculator nearby. But one thing that you're really not used to is seeing stuff that may be negative. So maybe I want to have something and I want to raise it to the negative 3 power. Or maybe I want to have something and I want to raise it to the 1/2 power. Or maybe I want to combine the fact that I can have negative powers and I can have fractional powers, and I want to think about raising something to the negative 5/2 power. And what does it even mean to raise something to the 5/2 power? I mean, we're used to seeing exponents where I have some base, it's raised to some power. Let's say I take 3 and I raise it to the 4th power. Well, that tells me that I multiply 3 by itself 4 times. But if I'm dealing with a negative power, does that mean that I multiply 3 by itself negative 3 times? Or if I have 3 to the 1/2 power, does that mean that I multiply 3 by itself 1/2 of a time? What do these things mean? That's going to be the purpose of this video. Let's start by thinking about fractional exponents. So first, let's consider the very basic one. You've seen 4 squared a lot, but what about 4 to the 1/2 power? So what I'm going to do is I'm going to take this 2 and I'm going to bring it to the outside. I'm also going to include a square root sign. So now I'm going to say that 4 to the 1/2 is equal to 2 square root of 4. So I'm not used to seeing a number right here. I'm used to seeing a square root sign, there's some number in here, but I'm not used to seeing something out here. So what does that mean? Anytime you see a 2 out here, it's no different from a normal square root. So if I'm taking the square root of 4, I'm going to come off down here to the side. I'm going to ask myself what number times what number such that these two numbers are the same is going to give me 4. So I know that that's going to be 2, because 2 times 2, the numbers are the same, it's going to get me back to 4. So since this thing is the same as the square root, I know that this is going to be equal to 2. Okay? Let's try another one. Let's think about 16 to the 1/2. Again, I'm going to bring this 2 out. So let me just do that. That 2 is going to come to the outside. I'm going to write a square root sign. So it's going to be 16, radical sign, put in a 2, and that's going to be equal to 4. So really, all that I'm doing when I raise something to the 1/2 power is taking the square root of it. So that's not too bad to think about raising something to the 1/2 power as being the same as taking the square root of something. But let's see something a little bit unusual. Maybe I want to raise 8 to the 1/3 power. But how, oops, my bad. Now this has to be different from what we've seen before. Like maybe I could think about 8 to the 1/2 power and just write that as square root of 8. But what do I do with this 1/3 power? So let's try and convert sort of similarly to the way we did on our last slide. So let's take 3 and bring it to the outside. We're going to set that equal to the 3rd root of 8. So we've taken a term with a fractional exponent, and we've made it into a radical form. But now we have this problem of what we do with this thing. What does it mean to take the 3rd root of 8? So during the time that you've been in school, you've probably only studied square roots. So, again, all that was happening there is you would take the square root of 16, you would come down here and you would ask yourself what number times what number would get you to 16. You would figure out that that was 4, so the square root of 16 would be 4. Maybe you wanted to take the square root of 100. So you would come off to the side and you would ask yourself what number times what number would get you to 100. You'd figure out pretty quickly that that was 10, so the square root of 100 was 10. Now we have to think about this 3rd root situation. So similarly, the 3rd root of 8 is really saying this: what number times what number times what number, 1, 2, 3 times, because we're talking about the 3rd root. What number times what number times what number is going to get us to 8? Think about that for a second. Okay, so if I think about that, I realize that 2 times 2 gets me 4, and 4 times 2 gets me to 8. So the cube root, the 3rd root of 8, is going to get me to 2. Let's try another one. So let's take 27 and let's raise it to the 1/3 power. So we're going to take this 3 on the bottom and we're going to bring it to the outside. So now we're going to say that we have the 3rd root of 27. So that's asking ourselves what number times what number times what number would get me to 27. If I take a while to think about that, I realize that 3 times 3 is 9, and 9 times 3 gets me to 27. So the 3rd root of 27 gets me to 3. So we've thought about raising something to the 1/2 power, and we thought about raising something to the 1/3 power. So let's keep going. What does it mean to raise something to the 1/4 power? Maybe I want to say 16 to the 1/4 power. So I'm going to do the same thing. I'm going to bring out this 4, put it here, and have 16 to the 1/4 power. It's going to be equal to the 4th root of 16. That's asking me what value times what value times what value times what value 4 times. It's going to get me to 16. And if I think about that, I think 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So the 4th root of 16 is simply 2. So let's sort of summarize our rules. Let's say that I have some base a, and I'm raising it to the 1 over n. That means that I'm taking the nth root of a. And that means that I'm asking what value times what value, so on, times what value, oops, sorry about that, on out to the final value is going to get you to a. So you're thinking about the nth root of a, that's saying what times what, ultimately n times, is going to get you to a. And whatever that value is will be the nth root of a. So the main thing that I want you to get from this, I want you to be able to take something to the 1/2 root, something to the 1/3 root, something to the 1/4 root. Maybe I could even give you something that's 1 to the 6th or 1 to the 7th, and you would be able to figure that out based upon this general rule, that anytime I raise a to the 1 over n, that's the same as the nth root of a. But I'm still not doing everything that I want to do. So far I've taken, I believe, 9 to the 1/2 and Maybe I talked about 27 to the 1/3, and maybe I talked about some other value to maybe the 1/4. But what's similar about these? What's limiting us about these? Well, I'm talking about 1, something raised to the 1 over 4, something raised to the 1 over 3, something raised to the 1 over 2. What if I wanted to expand upon that and have some value raised to maybe the 2 over 5? How would I deal with some situation where the numerator, the top part of my fractional exponent, was not 1? Maybe I want to take something like 2 and I want to raise it to the 3/5. Okay, so I'm going to do the same thing that I did in the past. I'm going to take the 5, I'm going to go put it on the outside, I'm going to set it equal to 2, I'm going to put a radical sign, I'm going to put a 5 on the outside. But what do I do with this 3? Well, I keep that as the exponent of my 2. So I'm going to do the 5th root of 2 to the 3rd. Now, if I want to calculate that, I really have two options. So let's do both of those side by side, and you can decide which you like best. So the first way is to just simplify what I have under the radical sign. So I'm taking the 5th root of 2 to the 3. I can simplify that as the 5th root of 8. And this is a really interesting situation, because if I do this, what value times what value times what value times what value times what value 5 times, and try and figure out what will get me to 8, I realize that that's really hard to figure out what goes here. So this is a good problem in the sense that it tells you that there are going to be some roots, some problems with exponent rules that you can't really solve without a calculator. So you could put this into your calculator, and you would get out that the 5th root of 8, which if I wanted to, I can convert this back and say 8 to the 1 over 5, since this is 8 to the 1st, is going to give me 1.52, I believe, and I'm basing that upon a calculator that I'm using as I make this video. So the point is, I want you to be able to go from radical to exponent, as well as from exponent to radical. So here I started with a radical, I still have a radical, but now I'm able to go from radical back to the exponent. And the reason I want to do that is maybe it's easier for me to enter in 8 to the 1/5 in my calculator, as opposed to the 5th root of 8. At any rate, I want to be able to put this into my calculator and find that I get 1.52. It's just not something that I can solve easily by hand. Now there are some problems that you don't have to necessarily do our last process. You don't have to get to a point, in some problems at least, where you need to use a calculator. Let's consider one of those that's really similar to the last one, but instead of raising 2 to the 3/5, I'm going to raise it as 2 to the 5 over 3. And I'm going to try and find this thing without using a calculator. So I'm going to do the same thing as I did in the past. I'm going to take the 3, I'm going to bring it here on the outside, and that's going to be equal to this. So 2 3rd root, I'm going to raise that 2 to the 5th power. So let's think about what that means. That means that I'm taking the 3rd root of 2 times 2 times 2 times 2 times 2, 5 times. And now at this point, I'm going to choose to split this into two parts. This one and this one. So let's do that. This is going to be equal to the 3rd root of 2 times 2 times 2, and then it's going to, then I'm going to multiply that by the 3rd root of 2 times 2. Okay? So let's simplify it one more step. That's the 3rd root of 2 to the 3rd power, since we have 2 times 2 times 2 under here. Then we're going to multiply that by the 3rd root of 2 times 2, which is just going to be 4. So I have an interesting situation here. I've taken one big expression, and I've made it into a product where I have something times something. So why did I want to do that? Well, it's mostly because I got to this. I'm taking the 3rd root of 2 to the 3rd power. So if I have some base and I'm raising it to the same power as my root, so I'm taking the 3rd root of 2 to the 3rd power, then it becomes simply what's under the radical sign. So the third root of 2 to the third is simply 2. Then I'm going to multiply that times the third root of 4. So this part, pretty simple. This part, I could put this into my calculator if I wanted to, but it's perfectly acceptable to leave this as your final answer. So you started thinking about some value times 1 over n. Then we complicated it. Maybe we wanted some value times 2 to the third, or some value times 4 to the fifth. In other words, some fractional exponent where a 1 isn't in my numerator. You learned this general rule. If I have some a and I raise it to the n over n, and I'm just using letters here to indicate that this rule is going to work for any of my situations, I bring n to the outside, and I get the nth root of a to the n. I learned that it was possible to force that into some kind of really, really special situation, where if I take something like the fourth root of 100 to the fourth, that's going to be 100. Or I take the fifth root of 1,297, 297. In other words, whatever I raise my base to, if I'm taking the same root, the fifth root of this base to the fifth, it's going to be the base itself. So I can force something like this to look like that. So that concludes what we're going to say about fractional exponents, but what about negative exponents? So let's consider something like 4, maybe to the negative 2. So that's going to be 1 over 4 to the second power. That's going to be 1 over 16. Kind of weird to think about. Let's see how it plays out in future situations. Maybe I want to take 5 to the negative 3 power. So to do that, I'm just going to put a 1 over 5 to the positive 3 power, and from that I'm going to get 1 over, and 5 to the third power is simply 125. So let's look at one more example. So far I've gone through situations where I'm raising a positive base, but what if I wanted to raise a negative base to some power? So maybe we want to do, let's see, negative 3, maybe to the negative third power. Okay, so negative 3 to the negative third power. To get rid of that negative, we're going to make it a positive by putting the base over 1. So now it's 1 over negative 3 to the positive 3 power. So negative 3 times negative 3 is positive 9. 9 times negative 3 is going to get me to negative 27. So this becomes 1 over 27. So we can see that our general rule for negative exponents is just this. We take some base, and it's to the negative power, and we make it positive by doing 1 over a to the positive n. Alright? Let's combine our knowledge of fractional exponents and negative exponents to solve some problems. So maybe I want to consider something like 8 to the negative 1/3. So the power is both negative and it's expressed as a fraction. So I'm going to show you two different ways you can think about solving this. So the first one is to deal with a negative first. So let's take 8 to the negative 1/3. We're going to get rid of the negative by doing 1 over 8 to the positive 1/3. Okay, we're going to bring that down and we're going to do 1 over cube root of 8. And we're going to get that down to 1 over 2. Okay? Now maybe I want to do it a different way, which is perfectly acceptable. Maybe I want to take 8 to the negative 1/3, but this fraction is really bothering me, so I want to get rid of it first. So I'm going to make that the third root of 8 to the negative 1. That's going to become the third root of 1 over 8, which we can break into two parts. We can break it into the third root of 1 over the third root of 8. And so the third root of 1 is just 1, third root of 8 is just 2. So you can see, no matter if we deal with the negative part of the exponent first, or we deal with the fact that it's a fraction, we still get to that same answer. So I'm going to do one final example that's going to really culminate in all that we've learned in this video. So let's start with this. I have 9 to the negative 5 over 2. and I want to figure out what that is. So I really know that I have some options here. I could deal with the negative first, or I could deal with the fact that it's a fraction first. I'm going to go ahead and deal with the fact that it's a fraction. So I'm going to set that equal to the second root of 9 to the negative 5. Now, I'm going to think about that. I'm going to split it into, well, I don't know, maybe I'll go ahead and get rid of the negative. So I'll take the second root of 1 over 9 to the 5th. I'll bring that over here and I'll split it into some parts. So I'll say the second root of 1 over the second root of 9 to the 5th. So I know that the second root of 1 is just 1, so I'm going to go ahead and write that out. 1 over the second root of 9 to the 5th. Now I don't really know what the second root of 9 to the 5th is, so maybe I'm going to write it out and see if I can break it into two radicals. So maybe I'll write this. 1 over the square root, or the second root, whatever you want to call it, of 9 times 9 times 9 times 9 times 9. I'm going to do that 5 times. Okay, so that's going to be equal to 1 over, I don't know. I see 2 9s here and I'm taking the second root, and I see 2 9s there and I'm taking the second root. So maybe I want to say this. The second root of 9 times 9 times the second root of 9 times 9 times the second root of 9. So that's going to let things work out for me pretty nicely. I know the second root of 9 times 9, or the second root of 9 squared, is just going to be 9 itself. Because anytime I take the second root, or any root of some base raised to the same power, I get whatever that base is. Okay, so let's go back to our original problem. So now I know that the second root of 9 squared, is simply 9. So I have 1 over 9 times 9 times square root of 9, which I know is going to be 3. So I'm going to multiply that out, and if I need to, I can use a calculator. I know that 9 times 9 is 81, and 81 times 3 is going to be 1 over 243. So it's really neat because now I've taken this really odd-looking expression and I've been able to find an exact value for it using what I know about negative exponents, fractional exponents, and learning how I can take a really complicated radical like this and break it into separate radicals. That will conclude this video on exponent rules.